Hi friends, see in moving charges and magnetism part 1 we discussed about various factors, okay, that is up to force acting on a moving charge we have discussed, isn't it, okay, force acting on moving charges, that is in part 1 we discussed about magnetic force acting on moving charge, that is QVB sin theta, okay. Now let us discuss some more things regarding this chapter, okay. That is, for example, this is a conductor. Suppose the length is L, okay, and suppose this conductor is placed in a magnetic field. It is placed in a magnetic field with the axis. This is the axis of the conductor. Let this axis is making an angle theta with the field. For example, axis is making, okay, axis is making an angle theta with the field. And please, axis in the sense the length. See here, actually in this case the magnetic force, that means force acting on a current carrying conductor. When the conductor is placed at an angle, axis is making an angle theta with the field. That means the angle is between L and B. Between L and B, the angle theta. So here also you can take care like this, that is L cross B, L vector cross B, okay. This is current carrying. So simply you can get the force like this by cross product of this one. Cross product means modulus of L, modulus of B into sin theta, or magnetic force is equal to I L B into sin theta. So this is the expression for the current carrying conductor placed in a magnetic field of B. So here once again, if theta is equal to 90 degrees, force will be maximum. Why? Because sin 90 is equal to 1. Then the force, magnetic force, is equal to ILB newtons. The same way, if theta is equal to 0 or 180 degrees, that means opposite side, L and B. So sin 180, 90 plus theta cos 90 0 kabatti. So in this case the magnetic force is 0. So it is maximum when theta is equal to 90 and minimum when its theta is equal to 0 and 180 degrees. This is another important force acting on a conductor carrying current placed in a magnetic field. Okay. Now let us go to the next thing in this version, moving charges. Okay. Very easy chapter, but concept is very important to understand. So the next one is work done by magnetic force on moving charge. Okay. So work done and nothing but change in kinetic energy, delta K. So here work done is nothing but delta K. That means final kinetic energy minus initial kinetic energy is equal to work done by the moving charge. Okay. So Ke final minus Ke initial. Or here what we'll do is initial kinetic energy will be equal to final. We'll do one thing. Here kinetic energy initial is equal to kinetic energy final. That means half m ui square is equal to half m v square final. Initial kinetic energy is equal to final kinetic energy. You can take like this. Okay. So work done initial is equal to work done final. Initial kinetic energy is equal to final kinetic energy. Okay. So this is the expression for work done by the moving charge. Okay. Moving charge. And by the work done by the magnetic force. Okay. So this formula you can use in numericals. Kinetic energy initial is equal to kinetic energy final. Okay. Now let us go to the next one. Okay. Next one is Lorentz force. Very, very important, regularly asked in the examination. A scientist named Lorentz has given a expression. So what is this Lorentz force? Lorentz. Okay. Scientist named Lorentz force. So what Lorentz has given is Suppose at a time magnetic field and electric field. Suppose if any particle is kept in both fields, any particle, it may be proton or deuteron or any alpha particle which is moving, okay? So then both the fields acts at a time, that is magnetic force and electric force. This net force is called as Lorentz force, okay? This net force is called as Lorentz force. Lorentz, Lorentz force. So what is magnetic force? Just now derived QVB. Maximum means sin theta will be removed. Alage electrical force EQ or EE. Okay. So the force can be written in this fashion. F net Lorentz force is equal to EQ because E is a vector, E plus QVB. Q is a charge. This is V cross B. So this is the equation for Lorentz force. Electrical field, magnetic field at a time acting in any particle placed in that one. So F is equal to EQ or EE and Q into V cross B. Okay. So these formulas again important in the case of numericals. Lorentz force, particles kept in at a time magnetic and electrical field, please. Right. Now let us see some more numerical equations. Suppose if magnetic field is in this fashion, suppose if the magnetic field is in this fashion into the board, okay, this magnetic field is into the board. Now suppose if a particle is revolving in circular motion, okay, if a particle is revolving in circular motion, you can take electron, in other words, electron revolving, okay. Now in such cases, having some charge Q or E, okay, suppose it may be having some velocity V. In such cases, how to get the values of R? So when the electron is revolving, which force is helping it? The centripetal force. Okay, centripetal force will be helping the electron. Are you following the point here? So which force is helping? Already the magnetic force is there, magnetic field. And another is centripetal force. So F centripetal will be equal to F magnetic. So F centripetal into mv square by r, if r is the radius, small r, and magnetic force just now given QVB, of course sin theta maximum. Okay. So when both are equal, you can see this V gets cancelled. So R is equal to mv by Q. B. So this V is called as V perpendicular, please. V is perpendicular. That means V is perpendicular to the magnetic field, please. V is perpendicular to magnetic field here. The velocity is perpendicular to magnetic field, please. Magnetic field inside, V is in this side. Okay. So it is going in this fashion. So this is the equation for radius of the particle electron moving in a circular motion with linear velocity V. The mass of the electron, V perpendicular, charge Q, sometimes it is taken as E also, 1.602 into 10 power minus 19 coulombs, and B is magnetic field in Tesla or Newton per ampere meter. This is the expression for radius. In the same fashion, if you go still further, you can also calculate time period. Time period capital T can be, because when it is rotating, what is for one revolution? For one revolution, the distance covered is 2 pi r. So, distance is equal to speed into time, or distance by speed is equal to time, distance by velocity, or distance or displacement by whatever velocity is also taken as time. Distance by speed will the displacement by velocity. So, here distance and length are 2 pi r. 2 pi r by V. This is nothing but time. Distance for one revolution. Distance by velocity or speed, magnitude of velocity, speed. Now substitute this value and we'll try to interpret this one. Okay, and we know, see here we are having some equations here. What is time period? In other words, it is also called as 1 by frequency. 1 by frequency is equal to time period. Okay, now what I'll do is I'll try to put this value over here and see what happens finally in radius. So radius is equal to mv, okay, by qb. In this we will try to substitute this t value, that is mv by, that is m into v value substitute cheddam. We will try to substitute v value, m into v, v entendaloonchi 2 pi r by t, 2 pi r by t, this is v value by qb as it is. You can see r is mv by qb. V value is from this 2 pi r by t. So from this what you are having is expressions here, m 2 pi r q b into 1 by t into 1 by t. Okay na? So ikkada meeku chudandi, this is equal to r. ఇందులోంచి t ఎంత అయింది చూడండి, r cancel, this is equal to r again, m 2 pi r by qb into t. So what happens here? This is nothing but again what? T. Or you can take it as 1 by t as n. Okay. Here left side 1 is equal to m 2 pi by qb into n. N is frequency. N is frequency. And also we have several equations. ఎందుకంటే మీకు ఇవన్నీ చెప్తున్నాను, while doing numericals all these formulas you have to use, please. While doing numericals you have to use this one. Okay. Let me tell you one more equation. ఇంకొక ఈక్వేషన్ చెప్తాను మీకు, అది చూడండి ఒకసారి. So radius equation we got, we have in terms of time period also and frequency you are having, see, in terms of frequency and time period, see, qb is equal to 2 pi m into n, or qb by 2 pi m is equal to in terms of frequency. And also in the current electricity I given one equation, I is equal to q by t or qn. So I is equal to, I can write in terms of frequency q into n, I can write q into n. So you can substitute these formulas and thereby you can solve some numerical problems. Okay na? But please don't remember all this. Remember this formula, radius mv perpendicular by qv, qb, and t, relation between time period and frequency, and distance by velocity or speed, magnitude of velocity is equal to time period. Okay. Now this one I can even change in terms of momentum. In terms of momentum ఏమవుతుందో కూడా చూద్దాం. Let us try in terms of momentum. See, in terms of linear momentum, let us see what is momentum formula. Okay, what is momentum? We know momentum, linear momentum is equal to m into v. Okay, so this formula, radius formula, you can change in terms of momentum, p by qb. So r is equal to p by qb. Q is charge, b is magnetic field, p by qb. Okay, clear? Now again this one you can also change. What is relation between kinetic energy and the momentum? P square by 2m is equal to kinetic energy, because k is equal to half mv square, p is equal to mv. So from this what happened? What is p? 2m kinetic energy root. So put it here. R is equal to, in the place of p, root over 2m ke by qb. So this is another formula in terms of kinetic energy, charge and magnetic field and mass of the electron or whatever particle. Okay, root over 2m kinetic energy by qb. Clear? So please make a note of all these formulas. Many formulas I have given for you. All this you have to memorize in your brain, and as and when required in NEET and MCET problems you have to utilize. If you ask radius, you have to use radius, mv by qb. If you ask energy, you have to use energy formula. Okay. Now let us go to another important device, cyclotron. CYCLO, cyclotron. So this is an accelerated device, cyclotron. This is a device which is having a shape of two Ds, hollow type Ds, రెండు D ఆకారం ఉంటుంది, two Ds. Okay, inside it is hollow. These two are hollow inside. So in this what happened is magnetic field will be there. In this magnetic field will be there. Okay, into the board. Here magnetic field is into the board. Okay, so here particles are sent into that field and it is accelerated. So when it is accelerated, what happens? Both fields will be acting at a time. That is F net. That is Lorentz force. Lorentz force will be there. That is magnetic force and electrical force. Both at a time will be there. Magnetic force enti QVB and electrical force E. So F net will be acting how much? Lorentz force. E plus Q into V cross B. So this is the total force will be acting in the cyclotron device. At a time magnetic force and electrical force. Okay, na? It is accelerated. At a time magnetic force and electrical force. Okay. So here this is a device in which it is accelerated andi. Cyclotron lo em chestaru, particle accelerate chestam. It will be increasing. Okay, its speed. So here magnetic force act అయినప్పుడు QVB, electrical force act అయినప్పుడు QE. రెండు ఒకేసారి యాక్ట్ అయినప్పుడు EE plus QV cross B. Okay, right. Now because what all we are required for MSET, those only will be dealing. No derivations and other things here. Okay, so already given the equation here. So in this cyclotron, generally protons or deuterons, heavy hydrogen, and even alpha particles are also used, and those are accelerated. And just now given the formula for radius for rotation, mb perpendicular by qb, and relation between time and frequency inversely proportional. Okay, so from that you got some equation that also I have derived before. Clear? So this is the main function of the cyclotron. Here it is, the particles are accelerated. Now let us go to the next item, very very important one. Force acting on two parallel conductors carrying current in same direction and in opposite direction. Okay, na? So here what is happening is two parallel conductors are there. First of all, name it AB, CD. Let the distance between them is some D or A or R, whatever you think. Let the current be I1, I2. First of all, first case 1 lo same direction తీసుకుందాం. In case 1 will take same direction. Now here if you apply your right hand grip rule, see. So when you apply for here, what happened? The magnetic field due to this one, it will be here into the board. Here the magnetic field will be into the board, please. Due to the first conductor, the magnetic field into the board. Okay. Now apply your right hand palm rule. I told you in the part 1 moving charges. So palm rule em cheppanu? Put your fingers along the field. Thumb indicates the direction of current and this palm indicates the force. So here the force will be in this fashion. Force due to second conductor, due to first one. I mean force acting on second one, due to first one, F21. In the same way, due to this conductor, see what happens? Due to this conductor, what happened? The magnetic field will be outside. Okay? So here what happened? The magnetic field will be outside. Magnetic field will be outside. Okay? You can check it, see. Magnetic field, the fingers are coming outside. So here outside, bite vastundi. So when it is coming outside, you can apply again palm rule, see. Magnetic field outside, current in upward direction, palm is in this direction. Therefore, force will be here. So this is force on 1 due to 2. So 2 equal and opposite forces. So ikkada em avutundi? Attraction avutundi. Here attraction. So when two parallel infinity wires going on, distance between them is d, there will be force of attraction between them. Okay? Now same thing if you go in anti-parallel. And okay, for example, I1 in this direction and another one is I2 in opposite direction, separated by distance d. Then what happens? Same again, see. అదొంది మీకు చూడండి. Inside the board due to this one. Again this one, see, into the board. So in both cases it will be into the board. In both cases it will be into the board. See, you can check it. In anti-parallel if you apply, into the board. Here also see, into the board. So into the board apply again your palm rule. Into the board, direction of current, force. So this is force on first one due to second one. And what about this one? Here, field is going inside, current direction, palm is that side. So this is the force. So force acting on second conductor due to one. So here you can observe there is repulsive force between the conductors. So in anti-parallel we will be having repulsive force. Okay? In parallel, same direction you will be having attractive forces, please. And you have an expression also, force acting per unit length is given by, okay? You can use the formula either IBL or general formula also. Okay? Force enti IBL use chesi force on 2 due to 1. Okay? Force on 2 due to 1. F is equal to bill sin theta kada. So avadhi kattachu. Or you can utilize Ampere's law and also Ampere's law with followed by force acting on the magnetic force acting on the conductor. ఆ రెండు కాంబినేషన్ ఉపయోగించి కూడా కట్టొచ్చు. Ampere's law తో ఏమొచ్చింది మనకి? What is B? Mu naught I by 2 pi R or 2 pi D. 2 times if you multiply, what happens? Mu naught I by 4 pi. Mu naught by 4 pi to 2I by D or R by using Ampere's law. You can take this formula, mu naught by 4 pi 2I by D. This is the magnetic field. And again force acting on this one due to this one, bill sin theta. That means B, I and I1. This is I2. L. Okay? So, if force acting per unit length and F by L is equal to mu naught I1, I2 by 4 pi into 2. If you divide this one, it will get cancelled and gets 2 here. So mu naught I1 I2 into 2 by 4 pi Newton per meter units. Force acting per unit length. Parallel conductor. అర్థమైంది మీకు పాయింట్ ఇక్కడ రెండు ఇన్ఫినిటీ వైర్స్ ఇవి లాంగ్ వైర్స్. సో ఇఫ్ యూ వాంట్ ఫోర్స్ ఆన్ సెకండ్ వన్ డ్యూ టు వన్, ఫస్ట్ ఫైండ్ B here. I will get by using circuit law B for this one. I will get mu naught I formula ఉంది mu naught by 4 pi into infinity wire. Mu naught by 4 pi into 2I2 by D. I2 by D into 2 infinity wire. ఇదేంటి మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు దిస్ వైర్. మరి దీని మీద ఫోర్స్ ఏంటి? ఫోర్స్ ఆన్ 2 డ్యూ టు 1 బిల్ సైన్ థీటా. అంటే I1 B into L. I1 B into L. Or force per unit length is equal to mu naught I1 I2 by 4 pi into 2 by D. This is the entire formula. Don't cancel this 2 times. చేసేస్తే మీకు ఏమవుతుంది? mu naught I1 I2 by 2 pi D లేదా 2 pi R అవుతుంది. Okay? So final formula is mu naught I1 I2 into 2 by 4 pi D or R or A. This is the force acting on the parallel conductors. Please make a note, when direction of current is same, there will be attraction. When direction of current is opposite, there will be repulsion. You have seen, I have applied the palm rule and explained for you clearly. Okay? So these are the formulas for the parallel conductors. Now next one, the dipole moment of a revolving electron. Next one is dipole moment of a revolving electron, please. Okay? Let us see that one. Now suppose you can see here already I have explained regarding magnetic moment. This magnetic moment is also called as dipole moment. Dipole moment. This is what for a circular coil carrying current. Ideniki circular coil carrying current. You can see magnetic field is inside. Magnetic field is inside. So either you can use in magnetism M is equal to 2Lm or current carrying loop. This is the formula. M is equal to I into A. Ampere meter square SI units for dipole moment for a current carrying coil. Clear? So this is also called as magnetic dipole moment. Any doubts? Okay. Now let us try to explain clearly regarding the dipole moment. Suppose only one turn is there here. Then you can adopt this formula. Suppose number of turns are n, small n or capital N. So what will be the dipole moment for the current carrying coil? N, I, A. What is that one? N, I, A. Okay? And here n is the number of turns, please. N is equal to number of turns in the coil. So this will be the formula, dipole moment for a, it's a vector. Okay? N, I, A. I is current, A is area, and N is number of turns in the coil, please. Okay? Now area, because it's a circular area, you can take it as pi r square. So what happens? M is equal to N, I, pi r square. And r is the radius of the circle. R is the radius of the circle. And already I have given one more equation before in terms current density. I is equal to Q by T or Qn. Current is equal to strength of current is Q into charge into frequency. Charge into frequency. So here you can put this formula also here. So finally what happens here? Okay. Dipole moment M is equal to Nia, okay, Nia or Ni pi r square, Ni pi r square. Now I will try to change this formula now in terms of current. In terms of current, that is magnetic dipole moment is equal to in terms of current. అంటే ఏం చేస్తాను నేను ఇక్కడ I ఎంత అయింది from this I is equal to Q by T. I is equal to Q by T అంటే N into Q by T into pi r square లేదా 1 by T again టైం ఫ్రీక్వెన్సీ కదా. సో అది ఇది కన్ఫ్యూజ్ అవ్వకండి. ఇక ఫ్రీక్వెన్సీ ఇది చూడండి. M is equal, this is frequency. ఇది టర్న్స్. ఒక పని చేద్దాం, ఫ్రీక్వెన్సీ F వాడదామా? F వాడదాం ఫ్రీక్వెన్సీకి Q అండ్ 1 by T ఇక్కడ నెంబర్ ఆఫ్ టర్న్స్కి క్యాపిటల్ అని వాడదాం pi r square. So F is frequency, Q is charge, N is number of turns, pi r square is area. Okay? Clear? So finally ఈ ఫార్ములా ఎలా మారింది చూడండి. Sometimes Q బదులు E కూడా రాయొచ్చండి. Q because it's the charge of electron. So M is equal to frequency F, E, number of turns, area. Okay, FENA. FENA. Okay. Now you can see here, small equation will be coming here. Already we know what is time period. 2 pi r by V is equal to time period. 2 pi r by V is equal to time period. Or 2 pi r, time period ఇక్కడ వాడుకోవచ్చు కదా మీరు. వాడుకుంటే ఏమవుతుంది చూద్దాం. Okay, we will utilize the time period formula here. We will see what happens finally. Okay na? సో ఈక్వేషన్లో వాడదాం మనం. అదేంటంటే సియర్ M is equal to N నెంబర్ ఆఫ్ టర్న్స్ NIA. Okay, and what is here? I is equal to Qn. I is equal to Qn. ఫ్రీక్వెన్సీని కన్ఫ్యూజ్ అవుతుంది, F వాడదాం. ఓకే, I ప్లేస్లో అండ్ ఏరియా pi r square. Okay, now what I will do here, this is the formula here, and we know what is time period 1 by F. 1 by F is equal to T. And what is T? 2 pi, ఇక్కడ పడతాడు value. M is equal to number of turns, Q, okay, F. What is F here? What is F here? Okay, so 2 pi r 2 pi r లేదా v by 2 pi r is equal, because 1 by t ఎంత అవుతుంది నుంచి, what is 1 by t? Frequency. So v by 2 pi r. So v by 2 pi r into v by 2 pi r into pi r square. Pi gets cancelled, r cancelled. So what is left over here? What is left over? Number of turns, q, that is e. Here what is left over? V. And paina r by 2. So ev square r by 2. Okay, e check చేసుకోండి ఒకసారి, EVR EV square. See what we are getting finally, EVR by 2, please, EVR by 2. So finally I am getting what? EVR by 2, please. ఏమొచ్చింది మనకి డివైడ్ చేస్తే ఫైనలీ మొమెంట్, magnetic moment is equal to EVR by 2, where E is the charge of the electron, 1.6 in 10 power minus 19. V is the what? Velocity. Okay, R is radius, 2 is the factor. EVR by 2 వచ్చిందండి. Okay, na clear? Right. So once again check it so that you can get that value here. Let us go to the next one. Okay, so almost over now, the chapter is about to complete. So magnetic dipole moment in terms of radius, charge and other thing, we got it as EVR by 2. Suppose if you go in terms of angular momentum, in terms of angular momentum, MVR, okay, MVR, angular momentum. Okay, what happens we'll see. L is equal to MVR and we have capital M is equal to EVR by 2. When you divide this L by M, angular momentum by dipole moment, ఏమవుతుంది అప్పుడు? MVR by EVR by 2, పైకి వెళ్ళిపోతుంది 2. VR gets cancelled. L by M is equal to 2M by E, or M by L is equal to ఎంత అవుతుంది? M by E, E by 2M. Dipole moment by angular moment reverse అవుతుంది కదా, L into E, L into A, 2M into capital 2M. So this is the expression, ratio of dipole moment by angular momentum, that is E, charge of the electron by 2 into M, that is mass of the electron. Okay, now last one, torque acting. So already I have discussed all these things before, so I am still going at a higher pace. I am going. Okay, so let us go with a little higher pace. Already ఇంత ముందు నేను టార్క్ గురించి డిస్కస్ చేశాను. ఎలక్ట్రిసిటీలో అయితే PE cos theta, P sin theta, P sin theta. In magnetism, torque is equal to MB sin theta. Okay, so crossword P cross E. Here you can write P cross E, torque or couple. Here is M cross B, dipole moment, magnetic dipole moment into magnetic field. అలాగే ఇక్కడ పొటెన్షియల్ ఎనర్జీ కూడా మనం చూసాం. పొటెన్షియల్ ఎనర్జీ ఎలా రాసాం? మైనస్ P డాట్ E. ఓకే, ఎలక్ట్రోస్టాటిక్ పొటెన్షియల్ ఎనర్జీ. అలాగే ఇక్కడ పొటెన్షియల్ ఎనర్జీ ఇన్ మ్యాగ్నెటిజం మైనస్ M డాట్ B. సో ఇది ఎలా రాసాం? మైనస్ PE cos theta, ఇక్కడ మైనస్ MB cos theta. So for this torque, if you are integrating and within the limits theta 1 to theta 2, sin theta minus cos theta kabatti, finally you are getting here what? Work done, U final minus U initial, that is PE into cos theta 1 minus cos theta 2, because U final and enti minus PE cos theta 2 minus చూసుకోండి, minus PE cos theta 2 minus మళ్ళీ మైనస్ PE cos theta 1, ఫైనల్ మైనస్ ఇనిషియల్, మైనస్ ఆఫ్ మైనస్ ప్లస్ అవుతుంది కాబట్టి PE కామన్ తీసుకోవచ్చు. సో దిస్ ఈస్ ద టోటల్ వర్క్ డన్, U ఫైనల్ మైనస్ U ఇనిషియల్. సేమ్ ఇక్కడ కూడా అంతే, ఇక్కడ ఏమవుతుంది? MB, ఇక్కడ PE అయితే MB ఇంటూ cos theta 1 మైనస్ cos theta 2 జౌల్స్. సో ఇక్కడ ఆల్మోస్ట్ సిమిలర్ ఈక్వేషన్స్ ఫైండ్ అవుట్ అవుతున్నాయి చూడండి, theta 1 మైనస్ theta 2. క్లియర్? So this is how you can write down regarding work done, potential energy in rotating from theta 1 to theta 2. Okay, clear all of you? Now this expression also you can change as and when. Okay, yes. Now let us go to the last one, MCG, moving coil galvanometer. Now what is a moving coil galvanometer? I told you before also. It mainly measures very small amount of current, that are around nanoamperes. Around 10 nanoampere, 10 to the power of minus 9 amperes. Nanoamperes. Okay? And MCG can be converted into ammeter as well as voltmeter. I told you in the before chapter. Now how the function goes here? In MCG, if you observe carefully, a coil is suspended here. Okay? Between the powerful horseshoe magnets, which are radially cut. And it is suspended by help of a phosphor bronze wire, and there it is attached with a spring, and current is passed through it. And remaining directions of the force, already I told you, by using palm rule you can calculate. You can calculate the direction of current, please. Okay? You can calculate, this is the direction of the field, magnetic field. So when you are putting magnetic field, current direction, you can find the force. So here what happens, torque will be acting, two torques will be acting. Deflection and restoring. Restoring is due to the spring. So deflection and enti, deflection torque 1, force into perpendicence. Force and enti, IBL into perpendicence ante coil yokka breadth. If L is length, B is breadth, B is perpendicence. Appudu enta avutundi? Torque 2, torque 1 is equal to I, magnetic field induction, length into breadth, that is area. Suppose if number of turns are n turns, then deflection torque is equal to I into N into B into A. Equation 1. Same time what about kindane avutundi? Spring also produce one torque. That is restoring torque, couple or restoring torque. So that is, you can take it as torque 2. Let it be C into theta or unit twist. Suppose when it is ideal, ante rest lo undi coil. Rest lo unnapudu evavutundi? At some angle, torque 1 is equal to torque 2, or torque 1 minus torque 2 is equal to 0. Rest lo eppudu untundi body. Resultant torque should be equal to 0. So when you both equate the torques here, I into N into B into A, okay, is equal to C into theta, or from here I is equal to C theta by NBA. This C, okay, restoring couple, number of turns, magnetic field, area of the coil, rectangular coil, is a constant, NBA is equal to constant. Therefore then I is proportional to theta. Okay, this is the main function in the moving coil galvanometer. In tangent galvanometer, current passing is directly proportional to tan theta. In moving coil galvanometer, I is directly proportional to angle theta. If angle is more, current will be more. If angle is less, current will be less. Okay, clear? Please note down. And last 2 points left over, that one, and with that I'll end up this chapter. Sensitivity of the current and sensitivity of the voltage. So in bit questions they are asking regularly in the MCET exams and NEET examination. Current sensitivity and voltage sensitivity of the galvanometer. Okay? As I told you just now, I is equal to K into theta. Okay na? Now what is current sensitivity? Current sensitivity in galvanometer, and also voltage sensitivity in the galvanometer. Okay na? So here I is equal to K into tan theta. Okay? లేదా దీన్ని మనం ఇలా కూడా రాసుకోవచ్చు. theta by I is equal to K కదా, because I is equal to, okay, I can write in this fashion. See, theta by I is equal to theta by K theta. I'll write like this. Theta by I is equal to theta by K into theta, because theta gets cancelled. I is equal to K theta. So from here what happens? This theta by I is called as current sensitivity of the galvanometer, is equal to 1 by K. That is equal to 1 by, what is K here? Just now written now formula ఏమైంది? C by NAB కదా. C by NAB is equal to constant అని చెప్పాను. Put it here. C by NAB. So it will go to the top now. NAB by C. So this current sensitivity depends upon number of turns, area of the coil, magnetic field, and of course the C value. Okay, that is couple. So this is the formula for current sensitivity. In the same way you can calculate for voltage sensitivity. Okay, NAB by C వచ్చింది కదా, అలాగే voltage sensitivity కూడా చేయొచ్చు. voltage sensitivity ఏంటి? voltage sensitivity This also you can calculate like this, that is theta by V is equal to theta by IR. Because theta can cancel, V is equal to IR, Ohm's law. So this one again I can write as theta by, okay, theta by, what is here, I అంటే ఇక్కడ ఏమైంది k theta కదా. So I is equal to k theta into R, theta cancel, 1 by kr or 1 by k, what is k? C by NAB into R. So NAB will go to the numerator, NAB by CR. So again you can see voltage sensitivity, that is theta by V, depends upon number of turns, area of the coil, magnetic field, and of course couple and resistance. So these are the formula you have to remember regarding voltage sensitivity and current sensitivity. Current sensitivity NAB by C, NAB by CR. Okay, NAB by CR. Please make a note, prepare well for the moving charges. Very easy chapter. You can score marks in MCET and NEET. 2 marks are coming from this chapter. Okay. So this is the end of the chapter. Again we will be meeting in the next chapter.